Normally I get a thing that pops up about recording. It did not do that. Okay. All right. So today this is our objectives for today for class. We're going to talk about what statistics are and statistical thinking is. We're going to talk about the process of statistics, looking at discrete and continuous variables, quantitative and qualitative variables. We're going to talk about levels of measurement, and we're going to talk about the how to obtain a random sample, what bias is. We're going to look at section 2.1. We're not going to do the entire 2.1 today. I'm going to split it in half. We're going to do half of 2.1 today and then half of 2.1 on Thursday. There is an assignment that is due Thursday for attendance purposes. So in order for you to be marked here, even though you're in the Zoom meeting, in order to be marked here, you have to complete that assignment by Thursday. Today, I'll be able to give you all of the information you need in order to do the chapter 1 assignment. It's not very long and it's not too difficult. It's pretty simple. So you should be able to get that done with today's information. And I encourage people after the Zoom meeting's done, after we're done, to just jump right into doing the homework. And if we were in an in-person class, that's generally what people use the time for. I will finish the lecture early so that students can work with me present, basically. And I will pop in a little bit after the class, but not a ton. Most of the homeworks, I open it on Sunday, and then you have an entire week, and then it is due on Monday. The reason assignments are due on Mondays is because I know that 90% of the other online classes have homework due on Sunday, and I don't want you to stress out, but I also don't want you to wait till the last minute, because I get up at 3:30 in the morning, so I don't stay up very late. So if you're trying to ask me questions at 11 o'clock the night it's due, probably not going to answer. One thing that I think I pointed out when I was going through the syllabus, but I want to make sure that you know, there are 5 late passes. So each late pass will extend the time from the date it was due for 48 hours. So no matter when you apply that late pass, it'll still be due 48 hours after the original due date. But that gives you an extra 2 days, and there are 5 of them per term. I would recommend not using them all the first or second week, because this is an 11-week term. You cannot use a late pass on labs. Labs are due on the due date. They're a firm deadline, and they cannot be turned in late. All right. So let's go to our. Are you guys able to hear me still? Can somebody shout out, let me know?
Yes.
Yes.
Okay.
Yes.
All right. I had this little thing popped up that showed like speaker off, and I was like, I don't know what's going on here. All right. Let's go to the next screen.
I can hear you now.
You can hear me now? Yay, good. So this
Yeah.
vocabulary is not anything that you are going to need to know for a test or a quiz or even an assignment. This is just letting you know what things are. There are some things that I'm going to say, hey, highlight this or put a star on it. This will definitely be on the test. So kind of pay attention for those things, because since I write the test, I usually know what's on them. So statistics is just the science of the collecting data, organizing data, summarizing it, analyzing it, all of that, and using it to draw conclusions, answer questions. And it is a science. It is definitely, if you know anything about the scientific method, we really use a lot of those principles in stats. We also talk about providing a measure of confidence. You've probably seen it in like presidential polls and things like that, where they'll say something like that 46% of people are expected to vote for a certain candidate, plus or minus 3%. That would be your like measure of confidence, your margin of error. So we're going to talk about how to calculate that and everything also. That's a while down the line though. So the information that we gather is data or data. I use the 2 words interchangeably. I don't know why. Sometimes in the same sentence, I will use both the words. I'll say data and I'll say data. I don't know why. It's just me. I'm weird. So the data that we use is we gather this stuff to draw our conclusions and then analyze it and all of that. So it could be numerical like height, it could be non-numerical like gender or right or left-handed. So that is the data. Any information that we collect is our data. And one thing that's really annoying to me is that data is plural. So you would say the data are rather than the data is, but because it annoys me, most likely I will not say it that way. But just letting you know, if you see it written like that, even if it annoys you, it is plural. I know, very strange. Get that away, go away. Okay. So we're trying to determine whether data is misused. We're trying to determine to prove our own points. We're trying to offset anecdotal claims. We're trying to make it so that we can make the data work for us and make it make sense. And I use it all the time, even in things not teacher related, but then again, I'm a nerd. So I am weird like that. So let's talk about some important vocabulary. And yes, this is something that will be in your homework and on a test or on a quiz. So the definition of population, it is the entire group that is being studied. So it's everything that's being studied. So even if we're not polling the entire population, our conclusions are going to be applied to the whole population. So for example, if I was going to do a study of RCC students to determine if there's a correlation between the amount of time they study and the grade they receive, our population is going to be RCC students. I'm probably not going to poll everybody, but that's who I'm studying. I'm studying RCC students. So a sample is a subset of the population. So generally we would have to take a sample of the entire population because it would be really difficult to poll everybody. So the sample is a subset. It is the people that we're actually polling, that we're pulling out. So our example here would be, if we selected 50 RCC students and used their study hours and grades for the study, those 50 students would be our sample. All right, moving on. Finally, we have individual. So it is one member. So it is one person that is polled, or one person in the population. So one RCC student would be an individual. I'll give you all a moment to write stuff down. Make sure if I move too quickly, you holler at me and say, hey, can you go back or slow down or whatever, or if you need anything clarifying. I try not to be scary. Does anyone need another moment? Are we good to go? All right, moving on up. Okay, so generally the way I do this, if I was in person, I would hand everybody a Post-it note and I'd have you give me your answer anonymously, and we would do this. So I'm just gonna do a pretend class. So you're walking down the street and notice a person walking in front of you drops $100. Nobody notices that they dropped the $100 except you. You can keep the money without anyone knowing. Would you keep the money or return it to your owner or to the owner? So let's pretend that I had a class of, let's say 30 people. Let's say that I had a class of 30 students. In that class that I had 3 people that said that they would keep the money. I'm just picking a number. Let's say that 3 people said that they would, 3 people said they would keep the money. Therefore, 27 people would return the money to the owner. So therefore, 90%, oh, darn it. Stop doing that. Okay. 90% of our class would return the money to the owner. I don't know if that number is bigger or smaller or whatever. I can tell you that in high school students, the number would be significantly smaller. Generally in college, I get 1 or 2 people that say they would keep it, but I'm just making up numbers. Maybe. Okay. So I'm going to give you some definitions, and yes, this will be something on a homework assignment. So a statistic is a numerical summary of a sample. So a statistic refers to a sample. So above, this would be a sample of all RCC students. These 30 students would be a sample if I'm applying the study to all RCC students. And descriptive statistics describes the data through numerical summaries. Basically, I just did this by saying 90% of like, if I applied this, let's say, to the whole population, I'd say, okay, 90% of RCC students would return the money. Or if I was graphing data or putting it in a table or something like that, that is descriptive statistics. Any numbers I use to describe something in my sample is descriptive statistics. Okay, moving on. So once we described our results without drawing any conclusions, our summary is an example of descriptive statistics. So this right here is important. Descriptive statistics is just vocabulary that I will use when I talk. It is not necessarily something you're going to be tested on or on your homework. But whether something is a statistic or a parameter will be, which parameter will be our next word. All right, moving on. Once again, 27 out of 30, this is 90%. Let's go to the next word. So inferential statistics. So if I took the data that I have, I extend it to the population, or I analyze it and use it to make predictions, then this is inferential. I'm inferring something based on the results I got from my sample. This is where I'm inferring that out of the entire RCC population, 90% would return the money. Or if I applied it to, I don't know, all of Oregon or whatever, I'm making predictions based on a sample that I took. We'd have to have a level of confidence, which we're going to talk about that later. If you are applying the sample to the entire population, you have to have a level of confidence. Don't worry about that right now. We're going to talk about that later. This class is kind of an intro class. We don't even do much math. And frankly, the first class is never very exciting. We get to the fun stuff later. Thursday's more fun than this day. But the thing about stats class is it's like a whole new language. So we need all new vocabulary. But don't worry, we'll get to the fun stuff. So I can say, so my inferential statistics that I can say with 95% accuracy that between 85% and 95% of all RCC students would return the money. So what I did was my margin of error is 5% in this case. And so 5% below the 90% and 5% above the 90%, this is my level of confidence. So I'm 95% sure that between 85% and 95% of students would return the money. I am making a prediction based on the sample that I have. Questions so far? Are we doing okay?
Yes.
Oh, yeah.
Go ahead, whichever.
I don't understand where you got your 5%.
I just picked a random. I didn't calculate anything. So I
Okay.
picked it randomly.
Okay. So our 95 and our 85% are not anything we need to be that concerned about right now.
No, you're not going to get to that till probably week 7 or 8 to learning how to calculate that.
Okay.
I'm just giving you an example of what it'll look like.
Okay.
Mm.
Thank you.
I have a question.
Okay.
What's the statistics on the students passing this class?
It's really tough because there are terms where I have nobody that fails. And then there are terms where I have, 20% fail. It is really strange. And I'm like, what did I do different? And I don't really know what the difference is because I feel like I teach it pretty much the same every time. But I think now of the students that do all of their work, I would say that probably at least 95% of students that do all of their work pass the class. It's pretty rare for someone that actually does all their work for them to fail. The students that fail are usually ones that use all of their late passes the first week and that don't turn in a lot of the assignments and kind of disappear for a while and maybe even miss a test or two. So it's not generally, if somebody actually attends the class and try, it's pretty much they're going to pass.
Thank you.
That help? Kind of?
Yes.
Okay. All right, moving on. Okay, suppose that the percentage of all students on campus who have a job is 84.9%. So this is a parameter because it is a numerical summary of a population. So a population, and I have a screen that's going to have both vocabulary words on there. So give me a second. I'm going to have a good definition of parameter in a second. So when we are summarizing, when we are doing using data regarding an entire population, it's called a parameter. So this one would be a statistic because now I sample 250 students, and from that sample, I find that 86.4% of those have a job. This is a statistic because it is based on a sample. So if it's based on a population, it's a parameter. If it's based off of a sample, it is a statistic. So here it is right here. Yes, you will have to know the difference between these two. So I'm going to leave this here to make sure you write that down. A good thing to star this or highlight this or whatever you're using to emphasize, I need to know this, do that there. I'll give you a moment. Okay. Good. Anyone need another moment? We're good. Alrighty. Sure you holler at me if I move too fast. So the goal of inferential statistics is to use a statistic to estimate the parameter. We're going to be doing that a lot later on because most of the time it doesn't make sense to poll an entire population. Moving on. Okay. So this is the process of statistics. You will not have to recount this to me. I will not ask you to detail the process of statistics. I just kind of want to give you an idea. Since it is a science, I want you to kind of have an idea of how you would go about using statistics like professionally or to do any kind of an experiment. And it'll be useful for when you do your final projects, which don't worry about those yet. But yes, right. First thing you want to do is you want to identify your research objective. What question are you trying to answer? Because you're not going to start collecting data if you don't even know what you're looking for it to show. What question are you trying to answer? And you want to know, what is the population you're studying? Am I studying all RCC students, or am I studying all Oregonians, or am I studying, only RCC students between 18 and 25? Who are you studying? What is your population? Next, collect your data. So without even mathing it all out, collect your data. You need to use your proper data collection techniques, make sure that it's random, and collect your data. If you don't collect it correctly, then it's kind of a meaningless conclusions, because if I was doing all RCC students, but I only pulled those in math classes, it's going to be a little bit different depending on what you're polling, but it's going to be a little different than if you do random. Or let's say that I only poll nursing students, but I want to know something about all RCC students. So I know nursing students are generally the ones that are maybe a little bit more academically minded. Who knows? I don't know. I'm making stuff up. But there are certain characteristics of people who go into nursing that somebody who is going to major in like fine arts might not have. So you need to really think about how you are polling these people. Okay, move on. So many scientific studies are based on convenience samples, such as internet surveys, phone-in polls. These are not reliable. You've probably seen like on news sites where people put up polls. And I know that the Daily Courier in Grants Pass does it. It's a convenience sample because people, it's like if you're on the Fox News website and you poll it, your poll is Joe Biden doing a good job? You're going to get a very different result than if you're on the MSNBC site and have the same question. You're going to get very different results because it's a convenient sample. So you need to be really careful how you're polling people. All right, move on. Describe the data. So here's where you're going to math. This is where you're going to math it all out, do whatever analysis method you're going to do, and you're going to describe what your data says. What kind of methods did you use? What does the outcome look like? So describing your data is like kind of what I did with saying 90% of our class would give the money back. So that would be describing my data. So, and now, now that I've described the basic data, I'm going to do all sorts of stuff to it. I'm going to use math. I'm going to find my confidence interval. I'm going to do all that crazy stuff, report the level of reliability, all the math that you're going to learn in this term. That's number 4. Okay. Number 5, it doesn't give number 5. Next is going to be your conclusion, which I guess it does say report your level of reliability. So I usually, in my head, number 5 is write it all pretty, use pretty words. That's pretty much, you know, you're going to say, you know, the results state yada, yada, yada.
So if on the test we describe it as pretty words, is that going to be a passing grade?
I'm not putting it something like this on the test. So,
Okay.
but if you say something like, say it in a pretty manner, I mean, I understand that, especially since I said it, but it is basically that the thing is, you'll see as we go through this, the conclusions that they write out are like 3 sentences long. Who wants to write 3 sentences to tell you what your data said? I'm a simple girl. I want one good sentence. Just give me one good sentence telling me what your data says. Do not write me a paragraph. It's, you know, even though I talk a lot, I prefer fewer words when you're writing it out. All right. Good question. So here's an example, and we're going to talk about the different parts of this. So as I said, I'm not going to ask you to break it down and to break down the different parts for me. It is not going to be asked of you, and not in your homework and not in your test. So this is just an example to get you to kind of understand our methods. So these studies, there's a lot of studies that talk about batterer treatment programs. So somebody who, and this is specifically males who batter their female partners. This is not taken into consideration any other kinds of relationship. So they're trying to find ways to have programs that will help people not to batter their female partners again. So they are trying to compare a treatment program with just community service. So the research designed an experiment researchers did. They took 376 male criminal court defendants who assaulted or were accused of assaulting their female partners. They were assigned to 2 different groups. There was a control group and there was a treatment group. So your treatment group, they had to enter a 40-hour batterer treatment program, while the control group just had 40 hours of community service. So the batterer treatment program probably had some sort of therapy and things like that. So after 6 months, 21% of the males in the control group battered again, while 10% in the treatment group had further battering instances. The researchers concluded that the treatment was effective in reducing repeat battering offenses. So something interesting about statistics and science actually is that if you have a successful experiment, yes, you can kind of say, yeah, I think it's probably an effective thing, but they don't ever stop there. They will do more experiments. Almost every time you get a favorable outcome, you're like, okay, well, now we need to do this again. we need to do this experiment again. And science is kind of the same way. The final answer is never the final answer. They're like, oh, well, we studied this and we found that this drug works really well for XYZ disease. Okay, well, we're going to do more trials of this. We're going to keep testing it and testing it and testing it. That's part of why this whole cold medicine thing happened, where finally they said most of the cold medicines don't even work. They just keep testing and testing and testing. There's never a final answer. It's just crazy like that. All right. So we're going to break this down. Step 1 was to identify the research objective. So our research objective is to determine whether or not males accused of battering their female partners when assigned to a treatment program are less likely to batter again. This is the question we're trying to answer. We want to know if treatment programs work. That's what we want to know. Step 2, I'm moving kind of fast because you guys don't necessarily need to write this down. This is not going to be tested on. Step 2, collect your information. The information we did was we took 2 groups and put half of them into the batterer treatment program, and then the other half went to community service. And then after 6 months, we tried to determine how many battered again. Is anybody else wanting pancakes with all this batter? Just kidding. Step 3, describe your data. We're organizing and summarizing our information. So after 6 months, 21% of the males in the group, in the control group, battered again, while 10% in the treatment group battered again. So this is just describing our data. And then 4, we're drawing our conclusion. So here's where I said there's like big, pretty words, as I said. We extended the results, 376 males in the study, to all males who batter their intimate female partner. That is, males who batter their female partner and participate in a batterer treatment program are less likely to batter again. They use lots of pretty words. So that is the entire like start to finish process there. And basically, once you get to your final project, which obviously a little while's away, we just got here first day, you might want to revisit these slides and say, okay, what's my process? But other than that, this is not anything that you need to like write down for the test. Not that we're just teaching to the test. I don't do that. Questions? All right, let's move on. Some more vocabulary. Sorry about that. The rest of the classes will be much more exciting. Now, I won't be doing songs and dances, but they're much better, not so much vocabulary. Couple of words, variables. All your other math classes, you've had variables. We look at them a little bit different here. So our variables here are characteristics of the individual within the population. So if we were studying handedness, whether somebody's left-handed or right-handed would be your variable. If we were studying hair color, then hair color would be your variable. So whatever the characteristic is, it is the variable. So if everybody had the same height or all plants grew the same, it would be boring. We wouldn't need statistics and we would all just move on with our daily lives. I'm glad there's stats, though it's fun. Okay, this is important. This is something you will need to remember for you'll be asked about these. So qualitative or categorical variables. I generally say categorical because I like that word better. And I think of categories. So this is based on some attribute or characteristic. It's usually not numbers. Not always, but it's usually not numbers. But if it is numbers we don't do math with. So for example, a categorical variable would be a phone number, because we don't do math with a phone number. It's just a number. I don't usually do math with an address. So would be numbers you don't do math with, or other categories. So here's some examples: gender, zip code, hair color. Birth date, it could be or it couldn't be, depending on what you're using it for. Like if I'm using it for the fact that, I was born 2 years after Woodstock happened or whatever, that would be using it as a number and mathing with it. But if I'm not mathing with it, just saying, hey, my birthday's on this day, that you're not going to math with that. So it really depends. So numbers you don't math with, or things that are just words, like colors of something. Yeah, the colors of the cars driving past your house, things like that. Those would be qualitative or categorical. Quantitative, this only has one word for it, these are numerical measures. So these are things that we would actually do math with. You get meaningful results when you use it with math. So these are always numbers. Write that down. It's always numbers, and it's numbers you can do math with. Here's some examples. Temperature, number of days a student has studied, weight, height, how much money you make, how many hours of TV you watch, how many dogs you have, any numbers that you could do math with. I'll give you a moment to write it down. These are things that you would star. These are things that you're going to need for your homework and for the test, which the test is a few weeks off. So, but always thinking. Questions about categorical or quantitative? All right, move on. Okay, let's look at these different things to see if they are quantitative or qualitative. So Elizabeth Kavavic and others studied factors that affect eating habits of adults in their 30s. So these are the different things that they studied, and we're going to look if they're qualitative, categorical, or quantitative. So nationality. Nationality is qualitative because it is words. My nationality, I'm German, Irish, and English. There's no math to be done with that. Number of children someone has, that is definitely numbers you can do math with. So, I don't know even any more explanation of that. Household income in the previous year. Once again, this is a number you can do math with. Level of education. So this one's kind of tricky. So we're calling this qualitative, but if you're using it as saying, oh, my one of my grandsons is 2 grade levels higher than the other, then it becomes quantitative. So it really depends on that. But if I say, like, I have a master's degree, that would be qualitative. Does that make sense? So it really depends on what you're doing with it. The daily intake of whole grains measured in grams per day. This is quantitative. All right, questions on qualitative and quantitative?
Will you be very specific when you ask questions like these? So we know exactly what information we're trying to get. Like,
Yeah.
will you make it tricky, or will you make it obvious for us?
I really try not to trick people. If I trick people, it's by accident.
Okay.
I really try not to trick people because I want you to know the material. I don't want you to fall for tricks.
Okay.
So,
Thank you.
I'm not that kind of person. Well, I trick my grandkids all the time because it's fun, and I've earned that right because I raised their parents. But otherwise, no, I try not to trick people. So, yeah. All right. So let's talk about discrete and continuous. This also is something that you will want to know. So discrete and continuous variables, both of them are quantitative. So we're talking just about quantitative here. They have a finite number of possible values or countable number. So basically what a discrete variable is something that, for example, I can't have 3.67 kids. If I'm counting how many kids somebody has, it is going to be 1, 2, 3, 4, 5. It's a countable number. other examples, I have examples here. Okay, so they can't take on every possible value between any two numbers. So here's some, like, how many TVs were sold last week, number of red marbles, number of students in a class. So it's something that's countable, something that is, you're not going to have every value in between. So thinking back to like your algebra class, if I was going to graph it, I'm going to draw a graph here, you would lift up your pencil between the points. You're not going to draw a continuous line through them because it can take on this point and this point, but it can't take on anything in between them. Can't take on those values. So discrete variables have to be like a countable number of values. And it doesn't necessarily have to be an integer, but most of the times it is. But if, for example, but let's say that the cost to go to a movie is $7.50. I would have $7.50. And then if I buy 2 tickets, it's $15. And then I buy 3 tickets, it's $22.50. I'm not going to spend $18.75 on movie tickets. It's going to hit every multiple of 750. If that makes sense. So a continuous variable, on the other hand, it has an infinite number of possible values. They're not countable. So like, think about like rainfall totals. I can't have 5 inches of rain, which is a lot of rain, if I didn't have 4.75 inches of rain. So it's going to continue and it's going to build. And it can take on every possible value between the two numbers. So here's some examples: heights of students in class, time it takes to get to school, distance traveled, weight of baby at birth. If I was going to graph it, it would look like this. It would be continuous. I would not lift my pencil when I graph it. These are important. Questions on those? I'm going to do some examples, but questions? Feeling okay? All right, moving on then. This is just a pretty picture. Quantitative are discrete or continuous, qualitative or not. Just a picture because I like pictures and they're pretty. And I'm a weirdo. Okay. So we have this darn Elizabeth Kavavic again. We're going to talk about discrete and continuous. So I already mentioned number of children. Number of children is definitely discrete, because unless you're getting picky about like gestation or whatever, it's not continuous. You're not going to have 3.87 kids. Household income in the previous year, we call this continuous because I had to make $5.99 before I could make $6. You could probably make the argument about them rounding to the nearest quarter hour or whatever, but that's kind of splitting hairs. It's continuous. Daily intake of whole grains measured in grams per day. We generally call this continuous, but I mean, there's ways that you could be tricky on this, but it's continuous because you're not gonna, you can eat partial grams and I have to eat a 3.99 grams before I can eat 4 grams, even if it's all in the same bite. It's basically continuous. Questions? Once again, I'm not going to be tricky. Okay, moving on. Okay, so levels of measurement. This is something you will need to know, but I'm going to give you the ways that I look at it in order to determine the levels of measurement. This is probably one of the things that people struggle with a lot. So I try to break it down really well. I think this is the last piece of chapter 1. So let's break this down. So levels of measurement, our first level of measurement. This is a really good one to print off. If you don't print off any other page, this is a good one to print off. So first level of measurement is nominal level. This is our bottom level. This one is going to be categorical. It's going to be categorical. And order doesn't matter. So it's It's just a naming scheme. So basically it's something like, let's say I'm talking about the colors of M&Ms in a bag of M&Ms. Order doesn't matter. It's, you have blue, green, red. It doesn't matter what order I order or what order I put them in. Handedness, left and right handedness, order doesn't matter. Gender, order doesn't matter. Religion, favorite color, things like that. It is just, you know, we just have things that are labeled, but it doesn't matter which order they're in. So that would be nominal level. This is our lowest level, even though they're not really like low, high, medium, and all of that. So our nominal level is just categorical variables that order doesn't matter. That's what I always look for when I'm looking at that. Is it categorical? Does order matter? So our second one is ordinal. This is the same as the first. This is also categorical. Also categorical. I'm going to write it up here. This is also categorical, but order matters. Order matters. Probably going to go off the edge of the screen. Categorical, but order matters. So, for example, if I was looking at like level of education, you have kindergarten, first grade, second grade, third grade. You have associates, bachelors, masters. So order matters there. Grades matter, like A, B, C, D, and F. Those matter. Satisfaction. So what I'm thinking about is satisfaction is if like they give you how satisfied are you from 1 to 5, or from not at all satisfied up to very satisfied. Same thing with happiness. It could be, you know, a scale of happiness, or like, for example, in sports, you have first, second, third, and fourth place, like, you know, maybe sports ribbons. Order has to matter. It's categorical, but order matters. Okay, now we're going to get to the quantitative ones. These ones, I'm going to give you the way that I remember them, because this is the only way that I could remember them. So interval level of measurement. This is right here. 0 doesn't mean absence of quantity. This is the big part right there. Does 0 mean absence of quantity? And also the math that you do with it is usually addition and subtraction. So my favorite example is temperature. A temperature of 0 doesn't mean that there's no temperature. It just means it's cold. And I wouldn't say it's twice as hot today as it was yesterday. That doesn't make sense. I could say it's 5 degrees hotter today than it was yesterday. It doesn't make sense to use multiplication with something like temperature. So here's some examples. Temperature, calendar years. The 0 calendar year doesn't mean there's no time. Elevation, an elevation of 0 just means you're at sea level, but you can go below sea level. So just think about, does order matter, or does 0 mean absence of quantity? That's the biggest thing you're looking for. And the math you do with it is addition and subtraction. Because you're not going to say this mountain is twice as high as that mountain. You say this mountain is 1,000 feet higher than that mountain. Things like that. Make sense? Finally, the ratio level of measurement. 0 does mean absence of quantity. And the math we generally do with it is multiplication and division. Those are the two things I look for when determining if it's ratio level of measurement. So, for example, how much money do you have in your pocket? $0 in my pocket. That means absence of quantity. And I can have twice as much money as the person next to me. Or I can have half as much money as the person next to me. And then, so that's multiplication or division. So also think about like how tall something is. So if something is 0 feet tall, there's nothing there. That is an absence of quantity. And something can be twice as tall as something else. So here's my examples. Money in your pocket, height in feet and inches, weight in kilograms, time spent watching TV. I can watch twice as much TV today as I did yesterday. That's multiplication and division, and 0 time watching TV is an absence of quantity. I'm going to give you a moment to write that down. I know we're getting close to the 6:30 mark. We're probably going to go a little over that today, mostly because I was chatty ahead of time. But we will definitely be done before 7. Does anyone need another moment? All right, moving on. So let's do a quick, which level of measurement here? Gender. So gender is categorical, and order doesn't matter. Therefore, it's nominal because order doesn't matter, and it is categorical. Temperature. And thing is these were in my examples, but 0 does not mean absence of quantity. And the math I would do with it is addition and subtraction. Therefore, it is interval. Number of days a college student studied this week. If they studied 0 hours, that's absence of quantity. And they can study 3 times as much next week as they did this week. So multiplication and division, it's ratio. Finally, letter grade earned in stats class. Letter grades, they have a specific order, therefore it's ordinal. Questions? Right. So we are done with chapter 1. You have enough information to do the chapter 1 homework. If you keep track of which chapter we're in or which section we're in, chapter 1 is done.
So is that the hand in or the one and chapter 1.1, I'm assuming?
It's the one that's due Thursday. There's the chapter 1 assignment that's due Thursday. That's the one for attendance. So you have enough information right at this moment to complete that assignment. We're going to do the first half of 2.1, about another 10 to 15 minutes probably of math, and then we'll be done for the night. Okay. So we're at 2.1, organizing qualitative data. So we're going to look at qualitative data. We're going to look at a couple of different types of graphs for these. And we'll do more on this on Thursday. So first, remember that qualitative data is categories. It is not numbers unless it's numbers that you don't do math with. So the first piece of vocabulary is a frequency distribution. It lists each category of data and how frequently it occurs, the number of occurrences. So a frequency distribution tells you how frequently does that number show up. That's all it is. It's just fancy words for how many of these do I have? Do I have more vocabulary? No. Okay. Give you a moment. Make sure you holler at me if I move too fast. I'm happy to slow down if I need to. Nobody be shy. Okay. So raw data is data that has not been cooked yet. That's how I remember what it is. So when we collect when you collect data from a survey or an experiment or whatever, before you organize it, before you make it pretty, it is raw data. So like if I'm pulling M&Ms out of a bag one at a time, I do red, green, brown, blue. It's as if I just write it down as I pull it out, that is raw data. So haven't cooked it yet, haven't done anything with it. All I've done is listed all of the stuff that I have. I've done nothing with it yet. Here's ways that we can organize our data. We can use tables, graphs, we can use numerical summaries. There's more than this, but these are our basic ways that we organize data. And you're going to be learning all about all of them. So much information in your noggin. You'll be like, man, that Kleist, she is so mean, filling up my noggin. Moving on. Okay, so first thing we're going to do is we're going to look at a bag of plain M&Ms. Don't worry, you don't have to write all this down. I'm just going to show you how to organize it. We're going to construct a frequency distribution, which is basically just a table that tells us the color and how many times it appears. That's all it is. So we're going to create a nice, pretty frequency distribution, and then we're going to look at a couple of different graphs. So this is my raw data. As I said, it has not been cooked. All I did was, as I'm pulling the M&Ms out of the bag, I write down the color. I didn't really do that. This is completely random, but I could have been fun to do that because then I could have eaten them. All right. So in my table, what I did was you don't have to put the tally marks. This was just making it easier to keep track of them. You don't have to have the tally mark part, just the color, and then the frequency is fine. So you see, I have 12 browns, I have 10 yellows, 9 reds, and so on. So all I did was list all of the colors and how frequently they showed up. This is my frequency table. Frequency distribution. I'll write the word distribution here because it is the same thing. We just like to use fancy words to make us sound smarter. All right, next. So for relative frequency, we frequently use relative frequency because it makes more sense. Because if I have 2 different bags of M&Ms, they're not going to have the same amount of M&Ms in it. So I'm like, I had 12 brown. Oh, you only had 8 brown. It's going to make more sense to put them in like common terms, kind of bringing them in so that I could say, hey, 62% of my bag was brown. What percent was your bag brown? It's going to make more sense that way if we're comparing, apples to apples rather than apples to grapes. And so the way that we calculate relative frequency is you take the frequency of that something showed up over the sum of everything. So the total number. So I take how many of that specific color do I have over the entire, how many total we have. And so when we list all of this out in a table, it's called a relative frequency distribution. Once I give you an example, it's going to make more sense. Give you a second. Right. So what I did was I took the 12 brown that I had and I divided by the 45 total that I have. Because there's 45 M&Ms, 12 of them were brown. So 0.2667 were brown, or about 26.67% of my bag was brown. Did the same thing here. I did 10 divided by 45. So about 22.22% of my bag was yellow. So I do that with each of these to find the relative frequency. So now I could look at this and say, okay, well, 20% of my bag was red. What percent of your bag was red? And it really helps to compare apples to apples, as I said. Questions on the relative frequency table? Okay. So a bar graph. You've seen bar graphs. I think everybody has seen bar graphs. I hope you have. So our bar graph, we label every category. We generally, for categorical variables, we'll use either a pie chart or a bar graph. Pie charts are going to be Thursday. So we're going to label each category of data, and then you're going to create your bars. Now the rectangles are going to be equal widths. And the height of each rectangle is going to represent how frequent that shows up. It's going to represent the frequency or the relative frequency. So it'll look pretty much the same. You'll see, I'll show you the graphs for these and hopefully it'll help. We're almost done. Okay. So hold on a second here. Here's my frequency table. Here's my M&M's bar graph. So you can see the brown goes up to 12. The yellow goes up to 10. I know you've seen a million bar graphs in your life. This is what they look like. This is what we use for. Really, really important where you're going to lose points. Label, label, label. Make sure your y-axis has a label. Make sure your x-axis has a label. Make sure that you have a title. I don't care if your title is like kind of, maybe you think, hey, this is kind of a dumb title. It's repetitive. I don't care. Give me a title. You will lose points if you don't give me a title and label both your axes. So remember that. Titles and labels. Next, I'm going to do relative frequency, same thing. We have our relative frequency here. So the only difference between this one back here and the relative frequency is that my relative frequency is right here on the side instead. So as you can see right here, it's what, 27% or whatever it was, 26%. This would help, really help if I was, be useful if I had two different bags of M&Ms and I did like a side-by-side bar graph. I could compare the percents on them. So that's where this would be useful. If I just want to know what percent of my bag was green, I can see that with that relative frequency along the side. So this is a relative frequency bar graph. Once again, labels, labels, titles, label, label, title. We're almost done. 2 more slides. Okay, I've got this. Something that I never, ever, ever have used in my life, other than in this class on these 2 slides. So not even in homework or test or anything, but it is required for this class, a Pareto chart. The only thing difference between a regular bar graph and a Pareto chart is that we make the bars in decreasing order. So they look like this. They're pretty. They have the highest value on the left, and then it steps down to the lowest. I've never been asked to make a Pareto chart. It's never going to be in your homework. It won't be on a test, but it is part of what I have to teach you. So there you go. And that was the last slide. Questions?
I was just looking at homework 2.1. Let me go back here. And it was sorry. I'm assuming, so we work through the lesson and record your work neatly in the notebook. When you're finished, click.
Yeah. You don't have to record any work anywhere. I'm not really sure why it says record your work in the workbook. So you don't have to record it anywhere. Just watch the little video and then move on. I think
just watch the video and move on.
Yeah, I think there's a checkbox or something, but yeah, just watch the video and move on. Good question.
Okay.
All right, so next class, we're going to learn, I'm going to go through how to do for our first lab. This class has a lab required because many, many degrees require you to have a stats class with a lab. So what you're going to need for your lab, like in case you want to work along with me, what you are going to need for your lab is you're going to need 20 data values of continuous data. I don't care what it is. And I don't care what you're using. You can use whatever you want. If you want to look at 20 days of rainfall, look at 20 days of rainfall or temperatures 20 days. If you want to find, I don't care what you use. Now, I know people want to ask their friends questions and things like that, but think about the fact that we have 5 labs and then we have a final project. If your friends are going to be irritated by you asking them a lot of questions, you might want to wait and hold off on not use them for this lab. But if your friends aren't going to care, then ask them. But you're going to need 20 data values that are continuous. You can look at maybe 20 different countries' rainfall. I don't know. That could be cool. Whatever you want to use. Temperatures, rainfall, amount of money people make. I don't care. Whatever you choose to use. I need 20 data values of continuous. You're going to need 20 data values of categorical. There's a lot of things people have used in the past. I've had people go to their closet and just look at 20 pieces of clothing and write down the color. I've had people sit on their front door, their front porch and get the color of 20 cars that have gone by. I've had people eat Skittles and take 20 or, colors of the first 20 Skittles that came out of the bag. It doesn't matter to me what you use, just 20 data values that are categorical. Last, 20 data values that are discrete. Whatever you want to use, how many pets 20 people have. Take a look at the last 20 games of a certain football team and what their score was. You can look at 20 different players and see how many rushing yards they've had. I'm a football fan, so everything's football to me, but I love sports ones. Sports ones make me happy. So, I mean, penalties are fun.
Who were you rooting for yesterday in the college football national championship game?
I can't turn this off. Okay, hold on. Sorry. I can't get this to turn off. Who was it? It was Michigan and
Washington.
Yeah, I was voting for Michigan. That's why I couldn't remember who they played.
Okay. I'm out of this class.
Washington? I'm sorry.
No,
sorry.
I'm just kidding.
Okay.
No, I'm a Duck fan, but I had to root for the Pac-12 the last year that it's ever going to be around. So
yeah, I always kind of go against the grain. I mean, I grew up in San Francisco Bay Area. Well, kind of. I grew up in Santa Rosa, but I was never a Niners fan, and I've never liked the Niners. I'm a Packers fan. So
no, even worse.
I'm really hoping that
fan, so.
I'm really hoping that you're not a Cowboys fan, because are you a Cowboys fan?
Raiders.
Okay, I can deal.
No, I'm a Raiders fan.
I can deal with the Raiders. I can deal with the Raiders. They're kind of the rebels. So really, basically anything discrete. Make sure that it's numerical, that it is a quantitative variable, but just something that is countable. You can. I love sports, so sports scores is good. Penalties, things like that. Whatever you want, but make sure you get your 20 data values of each type. And we're going to go through how to do the lab next class. So I'm sorry to disappoint you, Eddie, with my sports choices. Hey, at least I like football.
Yeah, that's good.
Some of my favorite final projects have been things to do with sports. I've had some really good ones. All right. Any other questions or anything before we go? Okay, so we're currently being recorded. So if there's any other questions that you want on the recording, ask them now. I will turn off the recording in a second, and you can ask off the record questions. We'll do this every week. So any more on the record questions?
Question.
Okay.
If the my book isn't due to arrive for a couple weeks now, or the end of next week. So with the videos that are up each week, is that enough to do the homework?
Yeah. I don't do homework directly out of the book. So you'll be just fine. The homework is definitely helpful for getting extra example problems and reading it before class. I've found students really find it useful. They'll read the chapter before class, and then once they come into class, they already kind of have an idea. But it's not good. The first couple of weeks are really just a lot of foundational stuff, and so you should be just fine.
Sarah, do you have the Rogue app on your phone? The Osprey app?
I do, yeah.
So somebody on there was just selling the 5th edition for like $10 in the comment section.
Oh, okay.
So I would go on there and maybe see if they still have it.
Okay.
I had one. I had ordered the ebook, but I had a bunch of problems with it, so I returned it. And I found one there a girl actually gave me one that passed the class from last year. She wrote all the answers in it. I don't really have to do anything. I'm just going to copy everything that she has on there, and then we'll be good.
Okay. Thanks.
Oh,
Daddy.
wait. Is this being recorded still?
Yes, that's awesome.
No, I'm just teasing. She didn't write nothing in it. I have to give it back to her after class. But
So disappointed you are once you find out that the homework is not out of the book. Darn it.
oh,
Okay, I'm going to stop recording.